50 MHz antenna coupler. Firstly, I'll describe the circuit, then I'll give it a test. Many antenna couplers don't work above 30 MHz. That's because their inductors and capacitor values are too large. Here's an L-match antenna coupler especially designed for 50 MHz. It will match a variety of end-fed antennas for that band. That could be handy during these high sunspot periods where there's an opening on 50 MHz and you want to make some contacts but find you don't have a dedicated antenna for the band. One of these couplers and a length of wire, I'd suggest something that's high impedance, like 3 meters long, could be enough to get you on the air and making contacts on 50 MHz. If the circuit board you see here is familiar, it's because you've probably seen it many times before from an old Pixie QRP transceiver. I've removed all the parts except for the antenna socket. I'm just using the circuit board as a support, and you can see I've got a bit of angle aluminium that's just screwed to the board, and that is where I mount the sockets for the antenna wire. There's only a small number of parts. Right here is a toroid, a T50-6. There's 8 turns on it, which gives you 0.5 microhenry. As for the variable capacitor, that's a beehive trimmer. It goes from a few picofarad, maybe 3 or 4, up to a maximum of 30 picofarad. And I've attached some irrigation tubing. It's fairly soft-sided, about 12 or 13 millimeters in diameter. That fits snugly over the trimmer's cap, and that allows you to make adjustments without touching the trimmer, which is good if you're trying to adjust a sharp tuning antenna coupler. Better not to be touching the variable capacitor, especially with RF applied. As for the amount of power this will take, it's certainly fine for 5 watts, probably okay for a bit higher power than that. Just having a look at the underside of the board, I've just used some hookup wire to make some of the connections and form some of the links. In this case, there's a link between the earth here, one of the sides of the trimmer capacitor, and the black socket here, banana socket, so you can attach either a wire using it as a binding post, a terminal lug, or a banana plug in through here. And the red is your antenna, your end-fed wire, and the connection there goes to one end of the toroid and the other end of the trimmer capacitor, and the free end of the toroid goes to the center connection of the transceiver socket here, which is a BNC. Or if you prefer a circuit diagram, then here it is. Probably the hardest part to find is the trimmer capacitor. This was obtained from an old VHF FM transceiver, but you may still be able to get by with a smaller type of trimmer that uses a screwdriver to adjust it. Calling CQ using the FT8CN app, not hearing any stations, hoping that someone somewhere will reply, but failing that I could always check PSK Reporter to see if my signal has been detected anywhere. Despite no one being on 6 metres and no signals being heard on the band, PSK Reporter has come good with a report. If we have a look at the map, it's straight across the bay from me, so a distance of maybe 50 or 60 kilometres. So just check that logbook and it is VK3YE. So thank you for having your receiver set up and online. A distance of 58 kilometres and -6 dB, which is quite a good report. So this is our look at a simple L-match antenna coupler, suitable for a high impedance end-fed antenna on 50 MHz. My wire is about 5 or so metres long, so nearer to a full wavelength. Should still be fairly high impedance, though its radiation pattern may not be ideal. I'd probably be better off just to use a shorter length, say 3 metres, and maybe elevate its base a bit higher. So you'd have both a low angle of radiation and a length that's still high impedance and a good radiation pattern. Do you want to get the most from your portable QRP operating? Good Antennas is a great place to start. Find out how I succeed with my 2 books, Hand-Carried QRP Antennas and More Hand-Carried QRP Antennas. They're big sellers with favourable reviews from all around the world. To learn more, visit VK3YE.com or search the titles on Amazon.